Hello, welcome to another video here on the TURBIVAP channel. Today our conversation is about a very specific and crucial topic, the maintenance of steam turbines. The idea here is to clearly address the difference between the three levels of planned maintenance: inspection, minor overhaul, and major overhaul. Let's understand what each one means in practice and other details. Come with me. The distinction between these three types of maintenance is not only technical, it is strategic. A turbine stopped without planning, it generates a very high cost, not only for the repair itself, but for all the lost production. So, that's why reliability, efficiency, safety, they depend on a good maintenance strategy. Knowing when and how to intervene is key to optimizing the management of these assets. My goal here is technical clarity. What is done at each level? Why choose one and not the other? And how does this affect equipment management? We will start at the base, level 1, inspection. Inspection and maintenance intelligence. We can say that inspection is the foundation of modern maintenance for steam turbines. Our total focus here on diagnosis and monitoring of the condition. We are moving away from that old idea of stopping the machine simply because the calendar told us to. The evolution has taken us from purely preventive, time-based maintenance to predictive, which is based on the actual condition of the turbine. In what it is telling us, the defining characteristic of inspection is that, most of the time, it is done with the turbine in operation or during very short shutdowns. The objective is to collect data and generate intelligence about the equipment to detect problems at an early stage. By identifying wear and degradation trends, we can plan upcoming shutdowns much more effectively. A good inspection strategy can even allow us to safely postpone a larger review, like an overhaul major. There are specific programs of manufacturers that use advanced monitoring precisely for this purpose, to assess whether it is safe to postpone the opening of the turbine, thus optimizing the life cycle and operating costs. This is by mutual agreement between the manufacturer and the end user. But the part we observe is a typical turbine inspection. In fact, it is a set of techniques. So, first we have continuous monitoring with supervisory instrumentation, which already exists in the turbine. So we, following the parameters such as the axial position of the rotor, the differential thermal expansion, which will show us how this rotor and the housing expand with the heat, vibration in the bearings, which is a very rich indicator and that we can draw a lot of conclusions. It is the condition of the machine, being able to point out unbalance, misalignment and even more serious problems, eccentricity of the shaft at low rotations. So, analyzing metal temperatures at critical points and fundamentally at the temperature of the anchor bearing, the axial bearing there is very sensitive. So its temperature can indicate excessive friction, lubrication problems, oil contamination problems, even problems of material deposited on the turbine vanes, increasing axial thrust, even vacuum in the condenser. He is monitored. A vacuum that is too high with the turbine at low load can damage the vanes. In the last stages, in short, with the machine's own instrumentation, there are several parameters that we can analyze to detect and possible problems. In addition to the operational parameters, performance analysis is a crucial part of inspection. So we carry out both periodic tests to follow the trends and the measurement of the enthalpy drop, which reveals the precision, the expansion of the steam flow capacity and thermal balances also provide important indications. A simple and very effective technique is to plot the pressure of the first stage of the wheel chamber against the steam flow rate, and if this curve changes over time, it is a sign of internal degradation. I've already made a chapter here dedicated especially for this machine performance analysis. We can help with that too. Okay, I'm going to leave here on the card here the link for you to access the video and a more dedicated paper about it and that we did. Go there, access there to get informed. But you will see that in a very summarized and abbreviated way, we can get very close to the real condition of the machine by some calculations there, obviously knowing the concepts of the machine. Then we apply it and we can have a very good, very close view of reality. And of course also, we will have more punctual predictive inspections, but they are also essential. So the detailed vibration analysis we use in a portable equipment, called software, then, following well-known standards, we can detect misalignments, clearances in bearings, problems in the oil film we behave, analyze the rotodynamics of the machine, and even the beginning of cracks in the oil analysis as well. Then, collect and send to the laboratory following standards there, such as ASTM D4378. Contamination analysis standards, to check for water purity, particulate matter, oil degradation and, crucially, the presence of wear metals. So, Finding Babbitt particles, for example, is a clear warning of wear in bearings. Also analyze the trend of varnish formation. We also have specific standards for this. TURBIVAP can also help with this point, helping in the prevention and concrete correction of oil contamination in turbomachinery, whether it's water removal, varnish, flushing itself. Then consult us too. There is material that we have already done here. I'm going to leave it here in the in-depth card on this topic, about varnish and turbine water decontamination, thermography and baroscopy. So to see what's going on within infrared camera or thermography, we can identify hot spots in bearings, leaks, steam or associated electrical problems. Baroscopy, on the other hand, as I mentioned, gives us a real image of the internal condition of the pieces. So we insert a probe, a camera there, through access doors already configured, established in the machine, in the turbine, in the housing, so that we can be our gateway there to visually inspect the internal components. We go there to look at the veins of the first and last stages, and with this evaluation we can see erosion, corrosion in the deposit, cracks and damage caused, for example, by foreign objects. A good baroscopy before a shutdown is decisive to define the scope of an overhaul. If we are going to open the machine and we already know that there is a serious problem in the reading, we are already prepared for a more extensive overhaul. Or not, it is quite important to do this process. The power of inspection is not in a single technique, but in the combination of all of these. So, when the vibration is strange, the oil analysis shows something, the baroscopy goes there and can confirm or not what we were suspicious of in the diagnosis. So the diagnosis itself and the planning of the next stage increases exponentially. It becomes much more accurate. So now we're going to talk about level 2, okay? Then minor overhaul. So what do we do in this type of maintenance? If the inspection is the diagnosis and it points out that something needs to be done, but without the need for a total disassembly, in the case of level 2, minor overhaul or partial overhaul, this is the next step, logical. So it's usually a planned, shorter shutdown lasting 1 to 2 weeks, where we not only diagnose, but act to correct and prevent bigger problems. So the big difference is the key dividing line here. In minor overhaul, we don't normally open the main turbine housing. The focus is on externally accessible components and vital systems that surround the equipment around the turbine. The goal is totally strategic, so it is to optimize the total cost of maintenance and increase reliability, often in order to postpone a major overhaul that is much more expensive and much more time-consuming as well. So we fix relatively low-cost issues before they cause very expensive internal damage. So, specifically in the steam turbine, what we do in this type of stop, in this pit stop, the typical scope includes the inspection of the bearings. So we open the lids and usually not the whole casing, okay? We open the covers of bearings known as tiles and we visually inspect the shoes. There, we measure the gaps, look for scratches or signs of overheating in the Babbitt and perform non-destructive tests called NDT as a penetrant liquid to see cracks or ultrasound to check Babbitt adhesion to the shoe. We also have a lot of content here talking about it. TURBIVAP can also help in this type of analysis inspection with technical training, differentiated and very judicious. We can go there and help you do this whole step. Report all this there in a standard report. Quite meticulous. Contact this contact if you are interested. I will also leave here the link on the card and in the video description. In some cases, the alignment is already checked using technology, usually the laser or mandrel itself. We check the alignment between the turbine shafts and the driven machine. If there is the reducer, generator, pump, in short, we do these checks. Correct the deviations there with a shim. There is also a video here talking about laser alignment with the PRUF technique. People access here, there will be more information for you. Another detail is the revision of the lubrication system. So this system receives special attention. So we drain all the oil, open the main tank clean to remove sludge. We change all the filters, clean the heat exchangers, inspect the main oil pumps, emergency auxiliary. As I said earlier, TURBIVAP can also help in this matter of prevention or correction of oil contamination in turbomachinery, whether in the removal of water, varnish or performing the flushing itself. High-speed flushing or flushing varnish remover. They are totally different things. Contact us, it's for us to talk a little more about it. Valve maintenance, quick block control valve, the trip valve, the extraction valve are disassembled, inspects all your internals. We lapidary the headquarters, and ultrafine polishing. There at the headquarters to ensure perfect sealing. We also calibrate all actuators, tests and calibration as well. We take the opportunity to stop to calibrate instrumentation and test thoroughly every overspeed trip system, every part, instrumentation. It's all reviewed, checked and recalibrated. So minor overhaul is a surgical intervention focused on vital systems, without the enormous complexity of opening the entire turbine. It is a philosophy of preventing a small problem from becoming a problem. So, learning how to plan and execute a minor overhaul efficiently is a skill that can save your unit millions and avoid a lot of headaches in our TURBIVAP courses, available in remote and face-to-face digital formats. We dedicate entire modules to the planning and detailed scope of each of these maintenance levels. So, whether in the face-to-face format, we go to your company to talk, chat, your staff, instruct and exchange experiences. Get in touch. Take the TURBIVAP course to your company as well. Digital, face-to-face or remote format. It is a pleasure to be there in person. Personally, together with you, we will sit down to make a round table of our team with your team and exchange valuable experiences. Okay. Well, we have finally reached level 3 now. The major overhaul. So it's the complete renewal. So the general revision, just by the name we already feel that the scale is different. This is the most profound, complex and expensive intervention in the life of a turbine. Okay. It's open heart surgery. So what defines a major overhaul? Without error is the complete disassembly of the turbine, including the opening of the main casing and the removal of the rotor. All subsystems. There is no major overhaul if that. The goal here is to restore the original condition of the equipment up to that moment there, or even, who knows, improve it. And here's a key. Major overhaul is the great opportunity to modernize equipment. Like I said, with full access to all the internal components. This is the perfect time for us to install new technologies, such as vanes with different aerodynamics, more efficient seals that reduce steam loss. These and other upgrades can increase efficiency and power. So, for example, running a high-speed balance that has never been done before, changing monitoring, implementing more modern diagnostic systems. That's the great opportunity. Something of this magnitude requires gigantic planning that starts around 18 to 24 months before the stop. It is necessary to define a scope, detail it based on the manufacturer's history, expressions, recommendations. So, put all this there in a very dynamic 360-degree analysis by parts well in advance, such as reeds, special studs, some materials. Many of these materials are imported for local manufacturing. Others are imported completely. Mobilize specialized labor there. Tools, cranes, devices. So the execution here is a long and quite methodical process. So we're going to do the disassembly after the cooling, the insulation, the pipes are all removed. The upper carcass is carefully hoisted, followed by removal of the rotor, which is placed in an appropriate cradle. All these internal components, diaphragms, sealing rings, reed holders, everything must be disassembled, organized and identified. Detailed inspection must pass. Everything there is a rigorous cleaning. Each rotor vane and diaphragms must be inspected for erosion, cracking or deposits using non-destructive testing as a tool. Also penetrating liquid magnetic particle, ultrasound. The rotor is the most critical component. It undergoes a thorough warping check and non-destructible tests, also of high sensitivity, especially in the areas of stress concentration. In the strut bearings, the casing is also cleaned and measured to check distortions, warping, alignments, flatness, joint, plane, in short, a multitude of criteria, repairs, modernizations. So, based on the findings, we carry out repairs that can range from changing some vanes, to rotor repair in very controlled cases, application of anti-erosion coatings, in short, a multitude of approaches. And as I said, this is the time to install the planned modernizations. Then we can, after all this, think and start thinking about the reassembly of the commissioning, and that will also require absolute precision. Then the rotor will go through a high-precision dynamic balancing, including, as I mentioned, it is the high-speed balance, balancing at nominal speed. I will also leave the card here. I have talked a little about this before this. It may still need a blast to remove fouling from this rotor. The lubrication system will also receive a very fine, very thorough cleaning. There, through flushing, there are some types of flushing. Again, circulatory flushing, high-speed flushing, flushing varnish remover. TURBIVAP can help with these matters. Please contact us. In assembly, the control of radial and axial failures is quite strict, so any adjustment, it will make all the difference after the final alignment. The startup is a slow and gradual process, with cold and hot tests, monitoring the temperature vibration in various loads, to establish a new operational baseline there, and we will try to exceed that previous operating condition. So we need to adjust the point of an adjustment of this machine. Therein lies the point of behavior, her optimum point. This whole process accompanied by gigantic and quite bureaucratic documentation with all the reports and certificates from suppliers of contractors. It is clear, then, that major overhaul is another level of complexity in terms of time and cost. It is a heavy investment, but indispensable to ensure the safe and efficient operation of the turbine in the long term. So, comparing the levels to a strategic view to fix the differences, we will summarize this in a comparative table here that I prepared. So we're going to analyze it very specifically now, item by item here, to make this very clear to us. So inspection, minor and major overhaul of steam turbines. So, starting at the first level, the main objective, main scope. These basic activities perform typical duration of the stop cost relative main impact. Obviously, guys, this is a generalist view. Each manufacturer will have its own criteria, its demands, its calendar. Okay, but here is a general idea. So, inspection, the goal is acquisition, diagnosis, prediction. Main scope, non-intrusive, without opening the housing mostly. Tests during operation, steam consumption, efficiency, vibration, test during cooling at 0 duration to few 0 days. No one else will do anything in 0 days of complex to intervene. Anyway, it's there. Low relative cost 1x as a proportional ratio, increases. Predictability, informs planning for the second stage, which is minor overhaul, correction or prevention as well. So I focus on peripherals and subsystems. Run-out test, sizing of bearings, couplings, valves, sealing and draining systems, lubrication system, a little more extensive. The relative cost is already a little higher. Increase reliability and postpone major overhaul. The major overhaul restores the modernization, dismantling all the basic activities and also the other functions there, and they're also taking advantage here to pass the schedule. So, planning in relation to the schedule mentions something about anticipation, about planning. So there is a very generic thing as well. Then, 18 to 24 months before, evaluate the fleet, anticipate repairs and ensure critical parts. Then, start discussions with OEMs and local teams to assess fleet conditions, review outage history and industry trends, anticipate potential repairs. Looking at the history says a lot to us, to identify long-term delivery parts and start planning purchases. Define the overall objective scope and expectations for the outage. That was 2 years ago, basically before starting. Basically, it's always working. The reliability people are always working on these steps 12 to 18 months in advance. Evaluate assets, secure resources, and define scope. Define the scope of interruption based on the conditions of the assets. Operational need, evaluate previous reports, secure contracts for parts, repairs and labor. Analyze the feasibility of training teams on equipment. Then we pull sardines to our side and if possible, in this break window end. Schedule a visit with us, a face-to-face, digital, remote training, whatever it is for us to exchange experiences with the people who will make this stop, integrate everyone about equipment and equalize team knowledge. Some have a lot of knowledge, others don't. There are no recent people in the team hired. Third, we can do it there. Modular together. Okay, he's coming to you, they're exchanging experiences, as you say, was leaving that guy, you know, talk like that, bearing LA, but where LA? No, LA bearing side coupled, blessed. And to avoid this kind of grotesque mistake, but which, believe me, happens, we are there to help in this regard. Direction of rotation, machine orientation, working principle that must be observed, must be analyzed in each component where that is the critical item. Where does it fence? People measure the place, inspect, check for clearance in a place that doesn't even have tolerance, so it shouldn't even be tolerated. In short, this type of situation saves time, optimizes resources and finally, defines the scope, the expectation, the more detailed methods for interruption, and then, from 6 to 12 months, ensure the scope, optimize operations and mitigate risks. Define the scope, start finalizing logistics, including crane availability, storage scope, work schedule, identify possible contingency plans for high-risk components, rely on countless, then predict type of situation, organize transportation, and preparation of tools to minimize delays, and then from 0 to 6 months before, validate the entire scope, preparing the feature, ensure flexibility, execution, warming up the engines. So we will carry out pre-interruption inspections to validate the scope of work, ensure that all material parts are prepared, ready, implement a detailed execution plan, interruptions, ensuring flexibility for unforeseen events. That's pretty much it. I'm not an expert in reliability. If you have more experience, more expertise, if you want to share something with us, then we have already held some meetings here just about that. If you also have something to share, get in touch with us, okay? The video I prepared today was this. I hope you enjoyed it. Leave your comments, your evaluation, share a little of your experience on this subject. Be sure to also get to know our courses, consultancies, our service in the area of steam turbines. If there is a job opportunity that can include TURBIVAP, I am very grateful. I thank you for your participation, for your company and your attention so far. A hug and see you in the next video. Was